My name is Gary Shepard. I'm from Stanford LP Gas in Midland, Michigan. This system injects propane vapor into an existing diesel engine. And it's a relatively simple system. Basically, the components that we use for this is the propane tank mounted on the vehicle. Out of the propane tank is vapor supplied to this control unit, mounted up out of the way. This unit will monitor how much power is being asked to be produced by the diesel engine using turbo boost. That turbo boost is then used to regulate the amount of propane vapor that's delivered into the engine. The engine still consumes diesel fuel, but at a lower rate, replacing that diesel fuel with more economical, clean burning, environmentally friendly propane. The operation that the driver sees in driving the vehicle is seamless. He doesn't need to do anything other than keep fuel in the propane tank. When he starts the vehicle, the engine started up, the system goes through about a 15-second delay. It automatically turns itself on. The driver, there's no human intervention to activate the switch. In terms of economics, cleaner burning out the tailpipe, reduced emissions, from years and years of doing this type of work, the system has some tremendous benefits. To specifically address safety concerns on the fuel tanks, the systems that we use are engineered and built to several different regulatory bodies. The Canadian Gas Association, NFPA 58, and several other engineering safety standards. The valves that are located, all openings on these tanks have excess flow and stop fill valves. This is the valve that's used to actually fill the tank. As this valve here, as the product is pumped into the tank, once the tank reaches the 80% fill, there is a stop fill mechanism located in the tank to prevent the tank from being overfilled. To verify that the tank is at the 80% fill, you can open this bleeder. This is simply a means to use to verify that the stop fill valve located here is in fact actually working. This is called a hydrostatic relief valve. In the event that the tank would happen to be overfilled, and on the unlikely event that that would happen, and the pressure inside the vessel rises beyond a preset value, this plastic cap is automatically popped off and the tank will relieve itself to equalize the pressure. This is the vapor delivery valve that goes to the engine, and it's designed and placed in the tank so that it only releases vapor to the engine. This is the liquid service port that is used for diagnostic purposes, or if there's an application that we need to be able to deliver liquid to the engine, then this port's used. This small aluminum fitting at the end is a means where a fuel level gauge is installed. That gauge then gives the operator the opportunity to verify not only that the tank is full, he can also visually see the volume of fuel that's in the tank. This is an electric fuel lock that is activated when the engine is first started. If the engine is not running, there's no propane vapor flowing. The second unit in the trio is a vapor regulator. These we preset depending on the size of the engine. And this is the heart of the unit. This is the regulator flow control. It senses turbo boost off of this bottom port. As the boost pressure rises on the engine, meaning we're asking it to produce more power, more propane vapor is delivered out the end of this control unit directly into the intake of the engine to satisfy the power requirements.
Ready.
This unit is able to be installed and calibrated on a wide range of diesel engines. The adjustability is such that it can be used on smaller motors all the way up to large stationary engines. And in all of those applications, it enhances the performance, reduces the cost, and improves the emissions.